Hello everybody, this is Avantik here. Let's start with basics of TensorFlow. These are the topics we'll be covering today. The first we'll be getting into Hello World. After that, graphs, session, fetches, data type, tensor sequences, variables and placeholders. This apparently works as building block of TensorFlow. Let's try to understand them. First thing first, to make sure that you have installed Anaconda and TensorFlow on it. Okay, to install Anaconda, all you have to do is go to this website anaconda.org. Click on download Anaconda and make sure you install the one with Python 3.6 version. TensorFlow do not come in pre-installed with Anaconda. So what you have to do, you have to use the command pip install TensorFlow and it will download 1.4 version of TensorFlow to your Anaconda. After doing the installation, make sure you restart your Jupyter notebook and apparently to import TensorFlow, what you can do is import TensorFlow STF. Next thing you should be doing is checking the version of TensorFlow that is installed. That will be tf.__version__. This is apparently true for every package in Python. Okay, let's see the hello world in TensorFlow. First, let's create a constant h which holds the string hello. This is how we do it. tf.constant. It is creating a constant which holds the word hello in it. The next one is Zeek. That's the word we want to hold in the next string. W word holds the string Zeek. Now we want to print hello Zeek. Okay, so we are using a concatenation or addition operator h plus w. And there comes one interesting part. Okay, if I execute hw now, you're not seeing the actual contents of it. We're not seeing hello Zeek over here. We're seeing some tensor information. Tensor, as we discussed in the first session, it is the smallest unit of storage data in TensorFlow. Okay, it will be storing n-dimensional store data. It is very similar to your NumPy. Okay, so it is showing a tensor object, but it is not showing the contents of it. We now want to see the content of it. So to do so, we want so what has happened so far? We have created two nodes. Okay, we have created two nodes, and which looks like this. We've created this constant and this constant one. Constant will be representing h and constant one will be representing w. Okay, and we have bridged a connection between them using this node add. Okay, what we need to do now is we need to execute the session. To execute session, we have to create a TensorFlow session. To do so, what you do here with tf session as ses. So inside this piece of width, whatever you write will be inside this session, and whatever you write outside this width scope, that will be outside this, and the session will be terminated. Okay, the session will be cleaned up. So inside this, okay, we want to create, we have created a session. Okay, tf session as ses, we have created a session, and this session should run, and we should pass the node along with which we want to call all the dependencies. If you see in this data, this is the result of add is hw. So if we call for hw, it will find all the dependencies that is required to execute this graph, and it will execute. Okay, so res is equal to session.run and hw. What will this do? This will run the session. This is the first line. This will run the session. So after you execute this line, the highlighted line, it should return you the resultant value of the string concatenation, that is hello Zeek. The second thing that we want to do is we want to visualize the graph here. Without that, the understanding is always incomplete in TensorFlow. To visualize that, we can write the graph in our file system. To do so, what we can do is tf.session.filewriter, and here you can see the location corresponding to the current directory where I'm running Jupyter notebook. Okay, I'm storing this graph. So let's execute this guy. Okay, it executes and it's done. Let's see the contents of RESTful. Boom, we see it. It's working. Great. So let's see the next stuff. Next stuff is we want to see the contents of the graph. How does it look like? Okay, so to do so, what happens when you install TensorFlow, it actually installs TensorBoard. TensorBoard is TensorFlow's graph, whatever graph it projects, it creates, right? The nodes, the edges, the tensors, the execution, operation, right, it will show you entire thing. This is a simple operation, but we'll be able to see the entire thing. To do so, make sure you have the TensorBoard exe as you see here, and you have the directory in which you are saving the file. So you can see log directory, new logs, and you can see here new logs. Since I'm executing this command inside my TensorBoard directory. Okay, that's the reason I have to give new logs, otherwise you can give the complete path. On doing so, what will happen is it has run a web server on port number 6006 on my local machine. So to see that, what we can do is we can refresh this page and we can see it's getting refreshed. There it is. So this is apparently the previous execution, and this is the current execution. So this is the output from my previous execution, this is the output from my current execution, and we can see the graph in this case. As we learn more concepts, we'll see more complex graphs coming to us. So far what we have understood is the fundamental concept of TensorFlow. So what we saw in this case, we have two edges which stores the data or tensors, and a node which actually does the computation. Okay, this entire ecosystem where you have edges, the nodes, is known as graph. Okay, and a graph is nothing without being executed. So this execution happens when you call a session with it. So there are two stages in TensorFlow code writing. One is creating the graph, next is execution of the session. We'll create a little more complex graph to see how it looks like. So here what you're doing, we're creating three constants a, b and c. Let's execute them. So we have created three tensors here. So we are creating three more tensors, d, e and f. D is multiplication of a and b, e is multiplication of b and c, f is multiplication of d and e. Okay, so you can see some operations over here. We want to execute this graph, and of course we want to see the graph as well. So what will we do? We'll persist this graph in the file system so that our TensorBoard can show it. Let's execute. Okay, of course we are very interested in seeing the result now. Let's see how does the graph look like. Okay, there it comes. You can see here you have a mini TensorFlow graph over here. You have a multiplication operation, you have an add operation, you have a subtraction operation. As you can see, these are the constants that we have created, and this is the output of the multiplication and addition that is going to this node, and the resultant is the one that we intend to achieve. So this was our little more complex operation that we could see now. What will you do now is we want to understand how this graph is. As of now, you can see everything in is getting added to the same graph. You can see here, this is the entire graph, and this is one mini graph out of it. This is other graphs. What we want to do here is we want to this is all getting added to the default graph. Okay, we want to create our own graph, because in your program you might have multiple graphs which is executing in parallel, making your execution really fast. Let's now create our own graph. Let's see. To create a graph, you have an API tf.graph. It will create a graph for you. Next time on, if you want, you can associate nodes, edges to this particular graph rather than the default graph. To see whether the current graph is default graph, what you can do is you can try out this tf.default graph. It will show you some address, and this graph, whatever you are creating, tf.graph, that will also create some address. If they are same, it will confirm you that both of them belong to same instance. Second thing, this is how you are creating the graph as we just now discussed. Now we want to create the entire graph of nodes and edges inside this graph. Let's see how to do that. Okay, g.as default graph. This is a very interesting piece of code. Because of this, whatever code you write inside this scope actually gets added to this graph. Okay, you can see here you are doing a.constant and print this value. So what is happening? All this node a and whatever we feel like adding more over here. Say we want to add b. Gets added to this graph. Let's proceed to the next concept, that is fetches. It's useful when you want just more than one information at one shot. Okay, so as earlier, what we have done is we have created a lot of tensors here, A, B, C, D, E, F, a lot of tensors getting created here. Okay, and you can see F is the one which is dependent on all of them. If we execute the graph with with F, it will actually execute the entire graph. Let's see how it works. With TF session S says output is session.f, so it will execute the entire graph. Now what we intend to do is we intend to get all the intermediate values visible. Either you can do session.run and keep writing the intermediate values, or you can do it one shot by passing it as a list. As you can see here, you are writing A, B, C, D, F. When you do out, it actually prints the last executed value of all these tensors. As any other library, it will also have its own data types. Okay. So to get to the data type tf.float, tf.int, of course it provides you casting packages, casting APIs. How to cast a tf? So this is what you are doing. Tf constant you are creating of type float, and you are casting this is a float of type 64. You are now casting to float of type 16. So this is how tf casting basically works. Let's understand one aspect when I talk about casting. So you'll see many times if you are not giving the right cast information or the right type information to the code, it will throw some errors which may not be so soothing to eyes. Very difficult to read and interpret many times. Okay, so this is basically because internally TensorFlow is written using C++ and which is very type strict. Okay, so it will ensure that you make sure you are always giving the right type information. Okay, casting is one way that can help you in many such situations. We can of course use NumPy and create tensor out of it. So of course any code that you have already written using NumPy, you have done a lot of computation using NumPy, but at the end of it you want to do a lot of computation intensive stuff with TensorFlow. You can very easily convert that into tensor and do the computation. Let's see how to create some sequence. TF linspace is one thing that you might find it very similar to NumPy. NumPy also has linspace, and as you expect you to do the same thing, but just make sure you're passing the data as a float here. It will complain in case you are not passing it as float. So start is equal to 2.0, stop 10.0, and number 20. That means it will generate 20 numbers separated equally, and D will be assigned to it when you execute. Let's see how it happens. tf.session, session.run B. So on running this graph, which have this node, it will execute, this O will hold all the data. As you can see in this case, this has 20 values, all equally separated. Similar to NumPy, so you will have fill function, ones, zeros, ones like, zeros like, you have all those utility. Okay. You can of course do all sorts of mathematical computation like matrix multiplication, do linear algebra, do any of these things. One of these examples is here. You have created a matrix and ensuring that matrix multiplication is supported on them, so that by having number of columns in one matrix equal to number of rows in another matrix, and you can do a TF matmul. Okay, of course, similar to earlier, what you will do, you need to execute this using a session. That's it. So now you can understand, right? No matter how complex mathematics is involved from your algorithm, be it machine learning or deep learning, all TensorFlow will do is it will convert that into edges and nodes of the tensor and operation or ops. Okay, and it can be executed. Another concept that you will find very useful when you are writing machine learning code is variables and placeholders. In machine learning algorithms, we'll see that you'll have model parameters. Just to correlate, we will get better understanding as we proceed further. Machine learning model, take for example linear algebra. You have model parameters. These model parameters, well, you get fine-tuned with every iteration. That's what happened in TensorFlow. That's what happened in deep learning. Okay, the model parameters get fine-tuned. Some variables will be there, the model parameters, which will be changed with every iteration. Okay, so this thing needs to be variable because they will be changed. So that's how I do it. Okay, so what you're doing here, you're creating variable. So this is the data. What you're doing here, you're creating data with normal distribution. Okay, some data you created and you're creating a variable out of it. So where is the variable which have this data in it? This is the value that is assigned to it. Okay, one important point about variables is without initializing them you cannot use it. So to initialize them there are various ways. One of them is tf.global variable initializer. It will initialize all global variable. Another is to do var.initializer. You need to call your session.run to this. This is another way to initialize it. Okay, at this point I will comment it. Okay, you can do session.run and var initializer. Just to see it here. Inside with you might have to write this code. This is how it will do. Okay. So if you have a lot of variables which are created above, what you can do is tf.global variable initializer. It will give you a handler to all the initializer of the global variables, and you can do session run in one shot. It will initialize all the global variables. Of course, if you want to see the output, you have to execute this variable itself, not the initializer. So there are two things you have to initialize. One is your initializer, and the other thing is the variable itself. This is placeholder. We'll see more usage of it as we learn machine learning and other concepts. Okay. Another thing is placeholder. See, whenever you're training a model, you'll be passing data from external sources, be it file, be it database, or some external source you'll be passing the data. So when you're writing your code, you need to create some placeholder, which is a promise that you will pass the data to it. Let's see that with an example. So what you are doing here in this line, you are creating a placeholder of type int16. That means later on when you execute the code, that time you promise to pass a int16 variable to it. Okay, see this is the node here, tf multiply ph and 2. So ph is a placeholder. So what it means is when I execute the code, I definitely have to pass this ph here, and let's execute it. So we have, this is one execution as you can see here. D is the output or tensor which is dependent on the entire graph. Okay, so we'll pass D and feed dictionary. This is how we pass value to the placeholder. Feed dictionary ph5. This is one value that is getting passed. Session.run, and this is another. So if we execute this, it will execute the entire graph. So we now have the value coming out from this execution. When you pass 5, this is the value. When you pass 15, this is the value. So this is how placeholder is. That's all as far as very basics are concerned. Next chapter we'll discuss more interesting topic. Thanks everybody.